All right, so I think I'm recording here. Let's take a look at these three quadratic equations. Um, for our first step is always going to be to write these in standard form, um, unless for some reason it's already in a different form that would be to our advantage to use it. But here I'm going to add x squared to each side. On the left-hand side, x squared plus x squared is 2x squared. Minus 17x. And I'm also going to add 35 to each side. So that equals 0. Well, here's a situation where the leading coefficient is not 1. So let's use that x method. That's a nice tool when this leading coefficient is different than 1. The middle term here is negative 17x. And we want to come up with two numbers that when multiplied together give us this, well, 2x squared times 35 is 70x squared. When we multiply the values, we want the top number here, but when we add them, we want the bottom. So a negative 10x and a negative 7x do the trick, because a negative times a negative is positive, and we get this 70x squared. And if you add these together, we get negative 17x. All right, so let's put this information in the form of a table and use the table to help us with the distributive property to factor this trinomial. So along one diagonal, I'm going to put the first term and last term. I've got 2x squared and 35. And along the other diagonal, I'm going to put the values that I found in my x, the negative 10x, the negative 7x. And I notice that that diagonal has both negative terms, and so I know when I factor here, I'm going to factor out negative values. So what's common to negative 10 and positive 35 is a negative 5. And vertically here, what's common to the 35 and negative 7 is a negative 7. A negative 5 times a negative 7 is positive 35. Horizontally here, if I look, the 2 and negative 7 don't have anything in common, but they do have variable x. And when I look here, the 2 and negative 10 are both even numbers, so I can factor out a 2x. That means that I can write this trinomial in factored form as x minus 5 times the quantity 2x minus 7, and that equals 0. So now that I have it in factored form, I can split this into two equations. X minus 5 equals 0, or that 2x minus 7 is equal to 0. We get solutions of x equal to 5, and here add 7 and divide by 2. All right, so let's come over. I'll shrink this up. Let's take a look at number 11 here. Let's get this in standard form. So I want to collect everything on the left-hand side. I've got 5x squared. Let's add 3x to each side. That'll give me 33x here, and the negative 3x on the other side will cancel. And let's add 7 to both sides, and that will give me a negative 56, and over here then I'll have 0. So let's again do our x method. Because that leading coefficient of 5, that's not 1, so it's going to make this a little bit harder. Our bottom term is 33x, and the first term times the last term, negative 56 times 5 is negative 280. All right, so two numbers when multiplied together give us this top value, but when added give us the bottom. The positive number has to be larger in magnitude. Obviously 280 times negative 1 is not going to work. But here's where it may just take a little bit of time to go through. And I'm going to go through it a little bit more organized than I would otherwise. Let's see. All right. So I think we found it here because positive 40 times a negative 7 gives us negative 280. But if you add these together, you get 33x. So that's why it's called trial and error. Sometimes it is faster when these numbers are large like that to just jump in and use the quadratic formula and do that. But here we just were organized. It wasn't easy, but yet it wasn't hard either. All right. So we've got 40x and negative 7x in the x. So we come over to a table, and along one diagonal, we put the first term and the last term that from our original equation. Now along the other diagonal, the two values that we found in our x. All right, so if we look at this, both of these are divisible by 4, right? No, both divisible by 8. I'm sorry. Right? Yeah. So I can pull out an 8, a negative 7, here just an x, but here a 5x. And so I believe that this 5x squared plus 33x minus 56 factors to x plus 8 times 5x minus 7. And if that product equals 0, then either x plus 8 is equal to 0 or this 5x minus 7 is equal to 0. So we have negative 8 or 7/5 is the solution to this equation in problem 11. All right. Let's take a look at this number 12. It's not in standard form. Let's subtract 2x squared from each side. We've got 5x squared minus 33x minus 14 is equal to 0. Again, the x method is probably going to prove useful. The first term times the last term, negative 70 x squared. So we're looking for two numbers that when multiplied together give me this negative 70, but yet when added give me this negative 33. So the larger one in magnitude is going to be negative. So if I try, well, here I found it pretty quickly. Negative 35 times positive 2 is negative 70, but when you add these together, you get negative 33. So we've got negative 35x and 2x. And now if we put this information in the form of a table, it will help us to factor and get our final, well, not our final answer, but it will help us to rewrite this quadratic equation in factored form so that it will be easy to see what the solution set is. So the along this diagonal is the first term and the last term. Along the other diagonal is what we found in our x. All right, so if I look at the negative 35x and negative 14, the common factor they share is negative 7. If I look vertically here, they share a common factor of positive 2. If I look horizontally here, they share a factor of x, and vertically here, they share a common factor of 5x. So x times 5x gets us 5x squared. X times 2 is 2x. Negative 7 times 5x is negative 35x, and negative 7 times a positive 2 is a negative 14. So that allows us to rewrite this trinomial as a product of two binomials. And now by our zero product theorem, we can split this into two equations. And easily get our solution set. Here, this is just a single step equation. Here, this is 2 steps, subtract 2 and divide by 5. And those are our two solutions to this quadratic equation. All right, so I hope that helps, and I will talk to you later. Bye.